Good morning, gentlemen. Today is Monday, June the 1st, and today we are going to continue our discussion of Chapter 15, which is entitled 15.3, The Speed of Light is Constant. Now, you recall from Section 15.2 the idea of catching a baseball that's thrown at the same speed from three different scenarios: a stationary, the thrower moving toward you, and the thrower moving away from you. Okay, and you know that if that occurs, you catch the baseball at three different speeds. All right. If you can't remember that, go back and review section 15.3 or watch the video again. I'm sorry, 15.2, and watch the video again. Now, the reason that I'm bringing that up is because it turns out that the speed of light is constant. In other words, it doesn't matter what frame of reference you use, the speed of light is always measured to be the same, always. All right. And so if you were to shoot a laser beam from a stationary target, or at a stationary target, from a stationary gun, then the laser beam would reach the target at 3.0 times 10 to the 8th meters per second. If you were to mount that laser beam on a spaceship that was moving toward you at some astronomical speed, the laser beam would still reach you at the target at 3.0 meters times 10 to the 8th meters per second. And if you were on shooting it from a spaceship that was moving away from the target at some astronomical speed, it would still reach the target at 3.0 times 10 to the 8th meters per second. All right. So contrary to the moving baseball in section 15.2, the speed of light is constant no matter what frame of reference we use. It always comes out to be 3.0 times 10 to the 8th meters per second. Now, the speed of light is abbreviated with the constant little c. All right, this is the c, by the way, from Einstein's famous equation, E equals mc squared. Now, the fact that the speed of light is constant no matter what the frame of reference confused many physicists for a long, long time. And it wasn't until Einstein published his theory of special relativity in 1905 that physicists really started to understand this. So let's go and have a look at Einstein's thinking, all right? Einstein started this whole discussion by looking at light in terms of the definition of speed. All right, now, one of the first things we talked about in this class was the definition of speed, right? What is speed? It's the amount of distance traveled over the amount of time, right? So Einstein looked at it as separate quantities. Speed, he said, was the amount of space that was traveled through compared to the amount of time of travel. All right, so we're still dealing with distances and times, but the amount of space traveled compared to the time of travel. And what he concluded was that space and time were actually all part of the same thing, which he called space-time. Very original verbiage there, don't you think? And so what he realized was that the constant speed of light, 3.0 times 10 to the 8th meters per second, unifies space and time. All right. If you are traveling a greater distance, then you're traveling with using less time. All right. Because, sorry, I'm going to sneeze. Essentially the sum of space and time gives you space time. All right. So if you're standing still, you're only traveling through time. If you're moving, then you're traveling through space and time. Well, it's the same thing with light, except that the speed of light is the constant that relates space and time. Right. So that, my friends, is section 15.3. Please make sure that you read that section in your textbook. It begins on page 215. All right. Have yourselves a happy Monday, and I will see you tomorrow.